Hello all, welcome back to our course on digital accessibility, and today we'll talk about what is multisensory interaction and we'll walk you through some examples of existing tech. Um, we have discussed the various aspects of including multisensory feedback systems and multisensory input systems in our some previous lectures, primarily probably in the universal principles of design session. You can go back and check it out. We also discussed about it in emerging input and output technologies lecture. You can go back and check that out as well. What we are going to talk about today is some specific aspects of multisensory interaction, and I also introduce you a new term which is called multimodal affective computing, and just a little bit of a glimpse of it, and so that you are aware of what all is happening in this domain. So let us start at the point where we want to understand what is multisensory interaction. So multisensory interaction in accessibility uses sight, sound, touch, or even smell or taste to create inclusive design, digital and physical experiences. Right? So I think we all are aware that we have these five senses, right? Touch, sight, taste, hearing, audio, and smell. Right? This is something we all learned in school. And so what now we are talking about in emerging tech and new solutions is catering to all or several of these modalities at once, so that we get not just inclusive solutions. So for example, if somebody is unable to see, they are able to experience the system or interact with the system through other means. Or for example, if I am able to see, but having multisensory modes enables me to interact with the system even in situational disabilities or in temporary disability conditions, right? So I, for example, am unable to visually give attention to a screen at a given point of time, but still the information is communicated to me through audio or through some feedback systems which are vibrotactile. So I'm still able to get an idea about what the where the video is or what the system is talking about, despite not having the need to continuously visually interact with the system. Right? So it also enhances overall experience of a person. Right? Because the system is not constantly seeking your visual attention, your audio attention, and thus or any other modality for that matter, and thus it's not a consistent cognitive load on the user, and that is what makes it a little bit more easier to interact with it. That's why we say that it enhances user experience. And particularly in terms of accessibility, of course, it's going to enable inclusion, because say people who have visual impairment, they have no access to one of the modalities, then relying on other modalities become even more necessary, and that is why the system needs to have multimodal interactive elements. So first, having multimodal interactive elements helps in providing alternative information channels for users with sensory impairments, such as audio cues for visually challenged persons, or visual alerts or closed captioning for hearing loss, etc. Enhances engagement for everyone, right, by catering to diverse cognitive needs. Right? So as I mentioned before as well, that if I am not constantly required to engage one of the modalities 100% with 100% attention with the system. I'm also able to relax my modality for snippets of time. I am also able to divide my cognitive load between modalities. So for a bit I am not watching the screen, but I'm just hearing. For a bit I am, kind of letting my ears and my auditory modality relax a bit and just looking at the pictures. So all of those, the combination can enable a better and enhanced user experience for everyone, and particularly with diverse cognitive needs, people with attention deficit, for example. So dividing it amongst modalities, dividing attention, the limited amount of attention that they may have in between modalities, can be really helpful. Also helps in making your content more memorable and intuitive through combined sensory inputs. So why do you think it makes it more memorable and intuitive? So imagine that you're walking in a forest where there is no, there, we're not talking about any systems, but we are trying to understand how human brain and modalities function, how human attention functions, right? So we are not engaging with any systems, we are just walking in a forest. And can you imagine how different modalities are engaged in experiencing the real world in a real time, in a natural setting where there is no artificially created sound or artificially created visuals, but you're just walking through a forest? How does one interact or experience the forest? You at all times may have visual input, which is you are able to see the pathways, the trees, the brooks, and everything. You are able to constantly hear different sounds like rustling of trees, rustling of leaves. There may be insects, there may be crickets, there may be animals, there may be bird sounds. There may be certain smells which are coming at all times in through different flowers, different types of trees. There is also tactual feedback where you are stepping in on a softer surface, say mud or stones, which are kind of pinching your feet. You are maybe also touching different trees, or leaves kind of touch your skin, and you are interacting with that as well. And you may also kind of pluck pluck an apple, or pluck a wild fruit and have a bite at it, right? So basically humans innately have interacted with the world in a multimodal fashion, right? And that is why it is more intuitive to interact in a multimodal fashion. Forcing the system in an artificial environment, what happens is traditionally developed technologies, they might require some particular kind of modality to um, be employed far more than other modalities, which may not have been the case in where our ancestors were walking through the forest, or even you today, if you go into a forest and walk through a forest. All your senses, like auditory and hearing in for those little bit sounds, and um, smell, catching up on those smells. So all of those have to be used. What has happened in the recent past, where most of the artificially created man-made technologies have required more and more visual attention to be the primary mode of interaction, and that has led to users, humans, to have diluted their other modalities like hearing and smell and taste and all of the tactile acuity and everything, right? So we are hardly really interacting with all of the other modalities. We are largely relying on visual attention, and that has um, kind of helped in advancing technology for the previous decades, past 2 decades to be particular. But in emerging tech and up and coming technologies are realizing it and trying to make use of multimodal interaction. So visual plus audio plus tactile plus this plus that. So I mean, all of those facets are now coming in form of interactive systems, and thus making it more intuitive, more tailored to the human way of thinking, right? So anything that is intuitive, that means literally that it is tailored to a more human way of thought process, and thus it makes everything a little bit more memorable also, because you are gathering information from multiple channels, and if at all there was an attention deficit in one of the channels, there is a better chance that your brain may have registered it through another channel. That makes multimodal information more memorable as well. So this approach moves beyond the traditional accessibility thought process, creates more richer, more holistic experiences for users with a visual, auditory, motor, cognitive, any disability for that matter. So in this image, we can see that how multisensory design functions, right? So designing experiences that involves all 5 senses or as many senses as possible rather than just one or two. Um, we are talking about sight, which involves movement, light, color. We're talking about sound, which helps us in governing distance, loud, quiet, all of those aspects. We're talking about smell. It helps us in identifying if something is fresh, if something is now stale, or is stinky, or all of those. It helps us in assessing the temperature of something that we are going to eat. It helps us in assessing texture, flavors. Again, touch also helps us in assessing textures, temperature, vibrations, and all of those through our senses, right? So a combination of multiple of these parameters can help us in engaging with the world a little bit better. So creating why we are using multisensory design, we're trying to create more inclusive environments for people with sensory impairments. And maybe we are asking some specific questions. So we can ask why, what is the desired effect, how, what is the desired experience, what objects elicit that experience. So similar sampling, primarily relating to real life, not man-made objects, so it would be easier to understand the intuitive aspects of multimodal design. What are the sensory experience going to be, and translate the findings in a coherent design. So what are the benefits of multisensory design or aspects of multisensory design? It is a cross modality design approach. It combines information across sensory channels. It by definition it becomes inclusive in its approach, because designing from the outset to cater a broader spectrum of abilities and not just as an afterthought. So from the beginning we are talking about that we will be looking at all of these or several of these modalities, and that kind of automatically enables inclusion because we are creating the system which can effectively be used by people with sensory deprivations and sensory impairments. Helps in making holistic experiences, integrating sensory inputs and like sight, sound, touch, smell, everything into a unified, meaningful experience. So, in order to get to it, all of these steps may be useful. So, you can check on that. Another aspect which is again part of emerging technology and emerging frameworks is something called multimodal affective computing, or MAC. And it also helps us in coming up or generating or developing holistic, unified experiences, right? Unified is very important, and it is also a very important aspect of something which you might have heard about. It's called IoT, Internet of Things. And why we are saying unified? Because one, the inputs may be not just through different modalities but also through different other parameters which are emotional, which are stress related, which are, and as a system, the environment is also kind of adapting to your emotions and then reacting and then telling you the feedback. That is where IoT systems come in. So what is happening in a multimodal affective computing is it also, so this is an interdisciplinary field. It is kind of it finds its roots in multisensory design or multimodal interaction. It uses multiple data sources. So modalities, of course, like facial expressions, voice, text, etc., as well as it also looks at psychological, physiological signals like heart rate, like stress waves, like brain waves, etc. So it basically it recognizes, it interprets and simulates human emotions, creating a more robust and accurate emotion aware system than just modality related approach, right? In a modality, what happens is that you await an input. Based on that, you can give a reactive output, right? Or you have to build in, punch in a lot of environmental conditions. But the moment we are saying that we want, now with emerging tech, we want customized solutions, we want personalized solutions, right? So the more personalization one would require, the more emotional and context aware the system has to be. In order to, for the system to be emotional and context aware about their users, there have to be other physiological signals such as EEG signals, heart rate signals, and all of those, so that the system can respond in an appropriate manner. So, what are the basic fundamentals of affective computing? So, the fundamental theory is that emotions are commonly defined according to models from the field of psychology. Then there is signal collection, so text, speech, facial expression, data, gestures, physiological data, and all signal emotion. Then there is collection part. Then there is analysis. This is where ML and AI models kind of come in, where we are saying machine learning and deep learning models are used for modeling and recognition. Then there is multimodal fusion, so fusing different types of emotional signals, improving classification accuracy. Generation and expression, so robots, etc., need methods for producing recognizable emotional signals as well. Right? So now with MAC, we are also talking about humanoid interaction. We're not just talking about humans interacting with systems, we're talking about humans interacting with robots as well. So by fusing information from vision, audio, text, and biosensors, MAC overcomes the ambiguity in single signals, enabling better understanding and modeling of complex human affective states for applications in personalized assistive technology. So this is just like intro to this terminology, and maybe you can kind of go and read a little bit about yourself if you are interested. You can search for affective computing, you can search for all of these terms, so signal collection in affective computing, theories of multimodal affective computing, then fusion of different signals, modal signals and emotional signals, all of this. Then there is sentiment or emotion analysis in affective computing. So you can go and kind of search and learn a little bit on your own, because this is a very technical model, and the course domain does not cover all of these aspects in very much detail, but I can have a separate session covering some other aspects of multimodal affective computing, particularly how it is used in personalized assistive technologies. So now let us walk through some examples of multimodal assistive technologies. To begin with, there can be multi-sensory alarm systems. So imagine that there is a fire alarm, it is only blaring sound. And if a person who is a person with hearing loss, they will not be able to even understand what the commotion is for. So there are these multimodal alarm signals which also emits light and as well as sound. Then there can also be tactile beepers or vibrators, particularly for people who are blind or who may have attention deficit. Then there are multi-sensory alarm systems which get triggered by multi-sensory input as well. So not just fire, but also heat or also smoke, so that it can be more effective. Then there can be braille plus audio textbooks, right? So then these kind of systems are also available where students with blindness, they interact with braille material, which is also audio tagged either through electronic systems or through, now we are also looking at solutions which are using augmented reality and gesture recognition for audio tagging of tactile material. Actually, there is a demo in upcoming session which you can also see. It's of a project called Talk Tile, where we are using augmented reality audio tagging, for tactile books and maps. So in one of the following sessions, you can have a look at that demo as well. And there are several more solutions which are available throughout the world in that domain. Then there can be interactive whiteboards, so using sound, visuals, touch. There's also vibratory feedback, and now with haptic gloves and virtual reality learning environments, this can become even further immersive. And I mean, smart boards is something which is already implemented in a lot of classrooms around the globe, including India, and that enables real time, visual, auditory, and tactile feedback for engagement. It's more fun for children as well as teachers to engage with also. Then there can be tactile maps and 3D models. So for geography or STEM learning, so these can be 3D printed, or they can be models again which are enabled through gestures. So audio is enabled through gesture. So as soon as you touch a particular part of the model, based on the position of your hand, the system is able to churn out an audio feedback and tell you about that particular building. Then I'm sure you all have already seen that in assistive navigation mobility, um, there are tactile pavings on the road, as well as beeping systems on the sidewalk and railway platforms. So one can also receive an audio signal about when the traffic stops and you can cross the road. Then there is also tactile paving, which helps you understand at what point on the sidewalk the the zebra crossing is placed at. This is something which we in India may be able to see primarily inside metro stations or railway stations. However, globally, it is something which is also very much inbuilt in the public road based infrastructure also. Then there can be like multi-sensory interactive rooms, particularly for autism therapy, using calming lights, textures, sounds, etc. For children who may be on autism spectrum. So as you can see in this image, there's also light. There are all kinds of different tactile furniture, so different kind of tactile inputs and sensory inputs, as well as visual inputs, as well as screen based inputs. All of those are present. Then in terms of wearables, which is again a very emerging aspect of technology in today's day and age, haptic navigation wearables use vibrations as well as visuals, and they largely rely on vibrations, because nobody's watching all the time, keeping a watch on their watch all the time. So they are also experimenting a lot with vibrotactile patterns, right? So for example, this haptic nav, they are providing haptic navigation solutions. So it's guiding people through cities, campuses, airports, and everyday life using universal language of touch. So it's like a navigation system which runs on your phone, also has audio feedback, also has tactile feedback through a wearable device. Then gaming and virtual reality. So controller vibration signals in games, events for players with hearing impairments, and so that they are able to get an idea of if the character is kind of banging in itself somewhere, or shooting, so there is also a vibration on the controller. Then there are more games which are enabling high contrast visuals or vibration in audio. So people with some light perception and some visual impairment can also interact with these games. Then there can be rehab technology, so multisensory rehabilitation tools. They help stroke patients to relearn motor skills. So there is a screen-based system. There's also audio guidance. There is also motor guidance, where the robotic arm is kind of guiding the hand for writing. Again, in public spaces and smart cities, so we, as I said, that in metro stations, etc., we might have seen that there is audio announcement as well as tactile floor guidance to help passengers navigate through the space and reach the respective doors. Then there can be other day-to-day interactions like elevators with spoken floor numbers, or as well as braille buttons. Then wayfinding signals, which uses high contrast icons as well as raised braille text. So, in summary, multimodal interaction enhances the overall experience of users, not just users with certain impairments or disabilities, but for everyone. It enables inclusion of various kinds of individual needs. Now, with emerging technology, affective computing and multimodal affective computing can allow for a high degree of personalization in the emerging tech, because now we are also looking at other physiological parameters like heart rate and stress level and EEG signals for interacting with the signal. So adaptive system behaviors can be designed using all of those parameters. So this is all for this topic, and I'm sure you are intrigued to know more about multisensory design, multisensory interaction, multimodal affective computing. So I would request you all to please do a little bit of a research and reading at your end as well about these topics, and we'll be happy to discuss in the forums or in the live discussion session as well. Thank you for joining today. I'll see you in the next session.